Ray tracing. There are three basic steps to draw this. So the first thing it says is draw parallel to the principal axis, then through F. I'm going to be doing the example where I'll describe this in detail. The second step says draw through F, then parallel to the principal axis, and the third one says go through C. So I'm going to teach this through an example. So here it says use ray tracing to determine the characteristic SALT. Now remember, S stands for the size, so is it bigger, smaller, or the same? A is the attitude. Attitude means is it upright or inverted? Like is it upside down or not? L is the location, and when we talk about the location, we're going to talk in terms of the focal point, center curvature, or the vertex. T is the type, and type means is it real or virtual? So once I do a couple examples, this will make a little more sense. So the first thing you do is you draw your principal axis. So you just take your ruler and draw a straight line all the way across. Next thing you do is you draw your mirror. Now, even though these are curved mirrors, we're going to draw it as a straight line. So once you draw your principal axis, which is just a straight line across the middle, and your mirror drawn as a straight line even though it's curved, then we can start following the steps. So here it says a concave mirror. Well, you need to know concave. Which one's that? So we're always going to draw our image. Let's pretend it's me. There I am. Crazy hair. All right, so there I am. So a concave mirror, it caves in the center. Caves in the center. Now, if this were drawn, which is a terrible circle, as a full circle, the center of the curvature would be there, and then halfway between the center curvature and the edge, which when it crosses with the principal axis, that's the vertex, is the focal point. So the focal point's always halfway between the center curvature and the vertex. And in a concave, I'll just draw that in a different color so you can see it. This is a concave mirror. The center curvature would always be on the left. All right, so we're back to this problem. So it says a concave mirror. So I know I'm going to draw this focal point on the left side, because the center curvature would be left, of 3 centimeters. So you take your ruler and you measure out exactly 3 centimeters. So I take my ruler is too long, and 3 centimeters is there, so I put a little dot there. And I'm going to put an F. So F stands for the focal point. It's where all the beams are going to focus. All right. If I know where the focal point is, I also know where the center curvature is. The center curvature would be 6 centimeters. So I'll line this up again. I'm going to put a little dot at 6 centimeters. And that's my C. That's my center curvature. Now, where the principal axis and the mirror meet, that's the vertex. So I'm just going to put a V down. Okay, once you've drawn all that, let's keep reading. It says an object 1 centimeter tall. We're always going to draw the object on the left side just so we're consistent and everyone does the exact same thing. So my object is 4 centimeters from the vertex. So I have to line this ruler up again. And so if that's 8, 4 centimeters is here, and it's 1 centimeter tall. So I would draw a line exactly 1 centimeter, and then you just draw little arrowheads coming down. That's the object. So we will always be drawing it on the left side. The object will always be on the left side. Okay, now let's go to our steps. So the very first step, which is written in red, so I'm going to draw in red. It says draw parallel to the principal axis, then through F. So what that means, this is actually easier if you do it on graph paper, is the principal axis is here, so I'm going to draw a line from the tip of the arrow to the mirror, the tip of the arrow to the mirror, parallel to the principal axis. That kind of looks parallel to me. So I just go to the mirror, and then you stop when you hit the mirror. You have to lift your ruler up. So that's the first part. So the first part of the sentence says, draw parallel to the principal axis. Now here's the second part. You stop, lift your ruler, and then we go through F. So you stop, you lift your ruler. Now where this red line hits the mirror, we're going to line that up with F. And F is right there. You line it up with F. Now, this is a mirror, so what actually happens is the beam strikes the mirror, and then, let me just make this a little longer, and then bounces off the mirror and goes through F down in this direction. However, if the beam were able to go through the mirror, which it isn't, it can't, it will when we do lenses. We're going to do these again with lenses. What we do is we draw a dotted line on the opposite side. Just shows the path it would take if it could go through. So it goes to the mirror, parallel, and then through F. So it looks like that. That's the first one. Okay, the next one I did in blue. It says, draw through F, and then we're going to stop and then do the second part. So again, we go from the tip, and this time we're going to go through F. So you take your ruler and you line it up. So it goes from the tip of the arrow through F, and it hits the mirror, and then you stop once it hits the mirror. There we go. So the beam, you stop it, you lift your ruler off, and the second half of that says, then parallel to the principal axis. So you always stop, readjust your ruler, and now we want to be parallel. I think that's parallel. There we go. So we draw a line. The beam actually bounces off and goes that way. Now, it can't go through the mirror, but if it could, it would follow this dotted line. We draw this dotted line so we know that it's not actually going there. But if it could, like in the case of a lens, that's the path it would actually take. And I ran out of ruler, kind of went a little down. Anyway, the last one I did in purple. So the last one's the easiest one. Okay, it says go through C. So what we do is you take your ruler and you line it up the tip of the arrow and C. So what happens is it goes to the mirror and then it bounces back and goes through C and crosses that way. Now, if it were able to get through the mirror, it would just keep going on that path there, and we just draw that as a dotted line. So, where the three lines cross, that's our image. That's where our image is actually going to be formed. So, my image, you're always going to draw it. You start at the principal axis, and you draw towards where the three lines cross, which in this case is down here. So, the black arrow is my image. Now what we're going to do is we're going to describe it in terms of salts. So you would simply just write down S-A-L-T. S stands for size. Well, my image is significantly bigger than the object I started with. So I'm just going to write bigger. A is the attitude. That means, is it upright or is it inverted? Well, it's upside down, so I would write down inverted. L is the location. Now, what we do is we talk about using these little letters. So if it's between F and V, you say between F and V. If it's between C and F, you say between C and F. But in this case, it's past C. So we can say it's outside of C or past C. I'm going to say outside of C. Now, the last one is it real or is it virtual? Well, when the solid lines come together, we always say it's real. When it's the dotted lines that all intersect, that's when we call it virtual. So real is when the beams can actually form an image over here. Virtual is when it's the dotted lines that all intersect. And we're going to do an example of that as well. Okay, so that's my first example. Here's my second example. It says a convex mirror has a focal length of 3 centimeters. So when we start, first thing you need to do is draw the principal axis and the mirror. So the principal axis will just be a line across your page. The mirror, even though we know it's curved, we're going to draw it as a straight line. Just makes it easier when we draw our diagrams out. All right, so I got my principal axis and my mirror. So next it says it's a convex mirror. So we got to figure out, well, which side are we going to draw all these things on? So again, we're always going to draw the object, I'm just going to say it's me, on the left side just to be consistent. And a convex mirror bulges out towards me. There's an exaggeration of a convex mirror just bulging out towards me. So if this were drawn as a circle, I'm terrible at drawing circles. The center of the circle would be here. And my principal axis is just a straight line that goes through the center. Where the principal axis and the mirror meet, that's the vertex. And the focal point is always halfway between the vertex and the center of the circle. So this time, I'm going to be drawing everything on the right side because that's where the center of the circle is. Okay, so now that I know where I'm going to draw it, let's actually start our drawing. So it's a convex mirror and it has a focal length of 3 centimeters. So we put our ruler down. And you're going to measure out exactly 3 centimeters. Put a little dot there. And put an F down. That stands for the focal point. I know where the mirror and the principal axis is. That's the vertex. So I can put a V there. And then if the focal point is 3 centimeters, the center of curvature is always double that distance. So the center of curvature must be at 6 centimeters. So I line this up again. Good to line up the 3 where I had it before. All right, so 6 centimeters is right there. So that's my center of curvature. So it says the convex mirror has a focal length 3 centimeters. Done. Once you know the focal point, we could draw the center of curvature. That would be double, so it would be 6 centimeters away. It says an object 1 centimeter tall stands on the principal axis a distance of 2 centimeters from the vertex. And remember what I said. We're always going to draw our object, just to be consistent, on the left side. So 2 centimeters is right there. So what I'm going to do is draw it. So it's 1 centimeter tall. So I'm going to draw a line exactly 1 centimeter and just draw little arrowheads down from it so it's exact. Okay, we need to follow the exact same steps. So to review, our first step was draw parallel to the principal axis. Let's do that. So you just line up your ruler so it's parallel to the principal axis and it goes towards the mirror from the top of the arrow. And then what you do is you stop. Once you hit the mirror, you stop, you move your ruler and you readjust. And the second part says, then through F. So when we readjust, you're going from the mirror to F. And we have to be careful because what happens is that because it's a mirror, the beam actually reflects off that way. However, if it could go through the mirror, it would follow this dotted path. So when the light beams can't physically get there, we draw it as a dotted line. So there's the first one. Parallel, and then you line it up through F. So everything on the left side will be solid lines, everything on the right side will be dotted lines. All right, the next one is in blue. It says draw through F, so let's do that. So you line up the tip of the arrow with your F, but remember, you only go to the principal axis. So we go right there, and you stop. You remove your ruler, and now we go parallel. And it's hard to go parallel on a blank piece of paper. This is much easier to draw on graph paper, I think, on parallel. All right, so what happens is it bounces off that way, parallel, but if it could go through the mirror, it would just be the dotted line. It would be that beam there. Now, the last one, the purple. So the purple is the easiest one to draw. It says go through C. So what we do is we line up the C, and again, it goes to the mirror and then it bounces straight back. That's easy. But then what comes through the mirror, we draw as a dotted line. All right, so there's my third one that just goes through C. And the one that goes through the center of curvature is actually hitting it at a 90-degree angle, and that's why it just bounces straight back or goes straight through. Now, where the three lines intersect, which is right here this time, we're going to draw our image. So you start at the principal axis, and we draw up. So now we have to do that salty thing. So you're going to write down the letters S-A-L-T. S stands for size. Well, this time it's smaller. E stands for attitude. So is it upright or inverted? This time it's pointing up, so it's upright. L is our location. So when I look, and you're always going to use the V, the F, and the C to talk about the location. It's between V and F. So I would say between V and F. So between V and F. And type, is it real or virtual? Well, on the left side, where we get our real images, these just keep spreading out more and more and more. So it's never actually formed on this side. But on this side, they all cross right here. But the beams don't actually get there. So that's when we call it virtual. And I know some of you are having trouble with the difference between real and virtual. In a plane mirror, it's always a virtual image because the beams just go straight, they go parallel and then straight back. In these curved ones, you have to look at your drawing. When it's the solid lines crossing, well, then it's real. When it's the dotted lines crossing, then it's virtual. And you're done.